everyone. Thank you for joining today's webinar on automation versus manual action in satellites. My name is Jack Coor, and I'm the research director at Payload. We have a very exciting topic today. We're going to cover everything from spacecraft automation, how it's evolved over the last couple of years, how that plays out in our panelists' missions, where manual operations is still necessary. And finally, we will close out with some big, fun ideas of the future of automation within our satellites. I'm very excited to introduce our four panelists today. To start off, we have Laura Crabtree, CEO and founder of Epsilon 3. Double shout out to Epsilon 3 for being the sponsor today, so thank you. We then have Abhi Tripathi, Director of Mission Operations at UC Berkeley Space Science Lab. We also have Paige Holland-Thielen, Ops Automation Lead at Muon. And then finally, we have Chris Tuttle, Principal Systems Engineer at Clearspace. And throughout the conversation, if you guys ever have any questions in the audience, please just put them in the Zoom chat and I'll try to get to them and weave it into our discussion here. But with that, we can jump right into it. I want to start off with a nice base for everyone. I want to just kind of go around, and if we can at a very high level, go around the room and just discuss your organizations, your missions, and perhaps how automation, since this is an automation webinar, how automation plays into those missions. So Laura, we can start with you first.
Sure. Hi, everyone. Thanks for joining. Epsilon 3, if you haven't heard of us, we are a software company focused on the ground side of things. So focused on integration, tests, and operations, and making your operations more efficient. We are very interested in automation, both from the ground and from the spacecraft side, and really excited to be a part of this and hear what everybody has to say today.
Paige, you want to go to you?
Sure. Yeah, I've been at Muon Space since about October. We just launched our first satellite in June. My role as Ops Automation Lead is basically to operate the satellite manually when necessary, and also to kind of forge the future of how to automate our processes. And our company mission is to kind of improve access to climate data through remote sensing satellites. So there's a lot of opportunities for automation there for gathering and sending data all over the planet. So that's what I do.
Great. And Chris?
Clearspace is a 5-year-old Swiss-based company who focused on in-orbit services, including and especially at first automated or active debris removal. So removing debris from orbit to protect the environment and hopefully give us space to occupy and use for generations to come. We're the prime contractor for the European Space Agency's first debris removal mission, Clearspace 1, which should launch in 2026. And we're implementing automation throughout our development and operations processes, from integrating our requirements software with the testing software, to test reporting, to operations in space. When we ideally the whole thing would be automated, but we need to have some human in the loop places. So we have a mix of automation in our space systems and human directed operations.
Great. Abhi?
Yeah, so I'm the Director of Mission Operations at the UC Berkeley Space Sciences Lab. We do NASA science missions. We have for decades. Our current satellites up in orbit right now that we control are a constellation of 5 satellites called Themis, 3 of which are around the Earth and 2 of which are around the Moon. We also have another spacecraft called New Star, and we're getting ready to do another 4 missions in the upcoming years. Next year, we have scheduled for launch the Carruthers Observatory, and then the Escapade twin spacecraft mission to Mars, which we are partnered with Rocket Lab on. Berkeley does everything for these missions, project management, systems engineering. They operate the missions, everything except the bus itself. For the bus itself, we contract with, like I mentioned, the Rocket Lab example, and then Ball Aerospace, Northrop Grumman, etc. Automation is very important to us. We run a very lean ops team, which is why so many people come to partner with us, because when you run a really lean ops team, you're agile and responsive to requirements, and you're also, quite frankly, affordable. And so automation is like our mantra. Long before I started at Berkeley, they went to one shift on-call operations for everything, and we are continually looking and evaluating new software and new practices to automate further, so that there's rarely anybody in the operations center itself outside of launch and commissioning.
Great. And you, all four of you, have been in the industry for a while. And Laura, this one's for you. Comparing satellite automation from maybe 5 years ago or 10 years ago, how has it evolved, and how has it changed, and what's driving that change?
Yeah, so I started my career at Northrop Grumman, and then I worked at SpaceX for a long time. So I saw early on a lot of manual processes from flight software and the ground side of things. I used to have to do command lookups, and the commands were like letters and numbers and not actual commands. And going from that to Dragon operations, which was more or less automated until we had to have some manual intervention for go, no go criteria for approaching the space station. But all in all, Dragon really took care of itself. But in the time that we started Dragon, it didn't do everything by itself. So over the course of the 10 years that I spent at SpaceX, we automated a lot of the things that we found so that our lives would be easier. And so I think it is going to continue to evolve both on the ground side of things and the spacecraft side of things for a number of years to come.
Great. And Abhi, you touched on what's driving this automation a little bit, but can you drive home that point on what's driving and what's drove in the last 10 years?
Sure. And I know, also having worked at SpaceX, like both Laura and Paige, I think we all come from a little bit of a shared experience as to why automation is necessary and important. One of the underpinning philosophies at SpaceX was you should always try to find a way to automate away as much of your job as you can. Okay. And that sounds scary to most people. Well, why would you want to automate away your job? Then what are you going to do? But the underlying principle there was that you would always want to be working on new, cooler stuff. And how could you work on new, cooler stuff if you were weighed down by this manual thing that you were also responsible for? So I think that philosophy was very critical at SpaceX and for its success, and why I was always pushing the envelope. And it's something that when I came to Berkeley, I was also pleased to see that they worked with the same philosophy, is that, you know, if you are manually tied down to something, then you do not have people freed up to innovate and people freed up to see what else you should be doing that everyone else in the industry might be doing or might not yet be doing, and be ahead of them. So I think, you know, that's a very basic philosophy for why you need to automate, to keep your people invigorated and excited about what the work is.
I have to chime in and agree. I have seen in previous companies places that did not take that philosophy of trying to automate jobs to make them easier and more interesting, and to provide their highly paid, frankly, engineers time to do more profitable things. And you get mired in a unautomated set of systems, and you start not seeing the horizon anymore. And it really, even to a corporate level, brings the vision. It really restricts the vision, and I think the future of the company, and it constrains automation hugely. So being at Clearspace is another place where automation is key, and I'm delighted to be in an environment like that.
Yeah, I think from like my perspective as an operator / operations lead / automation lead, it's kind of the sweet spot where I do operate the satellite. And so I'm the most familiar with how bogged down you can get with automated or with manual operations and, you know, the need for automation. I'm also responsible for implementing some of the automation, but also for advocating from the ground side and from the flight software side, what things we're going to need for the future to make the whole process smoother. And I can speak to my own experience as okay, if I have to push this button with this cadence, 5 times a day until the end of time, that's a lot of my time that's wasted that can't be doing, something better or improving on processes so that everybody's lives are easier. And so I think it's kind of a really good sweet spot to be at an early stage of a company, to be operations and automation, because I can get the best and worst, I guess, of both worlds. It would be nice to automate myself out of the operations side of things, but there's always going to be a need for some human in the loop. It just needs to be targeted and smarter and very, very deliberate and intentional.
Yeah. And Paige, when you're at Muon, so if we all agree that we should try to automate as much as the process as possible, at a startup like Muon, how do you prioritize which tasks should be kept manual or automated?
Yeah, that's a great question. I mentioned, I think, that our first satellite launched in June. So we've only been up there for 1 month and 20 something days. It's been a crazy journey to get here from the company's only 2 years old. The company is very small and lean. So a lot of the automation is the stuff that just doesn't make it into, the MVP version. We don't have a lot of features on our current satellite. It really was a demo and kind of a floating test bed right now. So anything that any features that get cut from flight and ground software eventually kind of land on the operator as burden. And so it's kind of my job to advocate for not letting that become cumbersome. So once we have payload that we're operating, that we're trying to gather data, we don't want to have a person manually sending commands all day, every day, to tell the satellite when and where to do these operations. It needs to kind of be a little bit headless. So we'll get there. With our first satellite, I think we did a really cool thing where there was a good balance between the amount of manual operations I actually have to do and the things that it does on its own. And it gives me a really good foundation for what to ask for and how. And some examples for what does it actually mean to operate a satellite when you actually have to think the different operated satellites at the very end of my time at SpaceX as well, but with a very established ground station network that belonged to SpaceX. So the difference with my current role is that we don't own the ground stations. We don't have as much coverage. So there's a lot of coordination with that in the loop as well too. So I have to decide when and where to take contacts, how often is too often, how long can I reasonably go in between contacts and let the satellite do its thing before I know what's going on. That was really long-winded, but there's a lot. There's a lot of room for improvement. But I think to get to the point where we did really amazing things as a super small, scrappy team. So pretty.
I think something that's important to note is we all talk about automation as something that we want to get to, but when you start out, that can't be the only thing that you think about. You have to sign up sort of ground rules for this is the plan for the future. And like Paige was saying, not everything is going to be automated from the start. So automate the things that happen 10 times a day that a ton about, and some of the things that you need to do that you don't know enough about from the beginning, learn about them. And then once you've learned enough, the process backwards, forwards, and sideways, then that the spacecraft or the ground can automate your job away. And then you, as the operator, only need to step in if something then goes wrong that you haven't planned for, that you don't know a lot about. And so I think it's important to note the difference between, yes, automate as much as you can, but you have to automate the things that you know a ton about already. And I think that was something that struck me when Paige was talking. Hey, I haven't automated these 10 things, but we built the flight software code to have the spacecraft take care of itself in the event of X, Y, and Z, because maybe I need to respond within a millisecond, so therefore the spacecraft needs to take control. Or maybe this is something I already inherently know a ton about because I've done ground testing to the nth degree. Anyway, that was something.
Yeah, just to riff off that a little bit, I feel like there's three levels that is a good framework to think about it. The first level is, what can I automate because it is just an absolute pain in the ass. It's driving down team morale because nobody likes to do that thing. Go attack those things first. Okay. The second thing is, what can I automate that would make my job a little bit easier? You know, everyone would say, if we have this cool thing, wow, this would be great. Let's go investigate. That's level 2. Level 3 is the hard one because it's the one that nobody has time for, but that will sneak up on you and hurt you if you don't plan for it, which is how do I scale? Like, I might not be able to scale if I don't automate something beyond a certain point. And, you know, at Berkeley, we're at the position where we were operating one large NASA mission every few years, and we were winning them serially. And then in 2020, all of a sudden, you know, it was a bonanza where we were awarded 4 missions and more might be coming still. And so we had to think about, oh my gosh, the way we were doing things serially cannot work anymore. We have to automate because now we're faced with the scaling problem. So I think trying to break it down into those 3 categories is a helpful framework for trying to figure out what should I automate now, but what else should I be thinking about automating in the future?
There's a question in the chat about where should we put the effort on automation on board, the space segment or the ground, especially from the payload planning point of view. This might be a Paige or Chris question.
I have a lot of opinions about this, but I'm talking a lot. Chris, do you want to?
No, please.
Okay.
I have opinions too, but
my hierarchy for implementing automation is the very first thing that you should aim for is anything that is critical to health and safety of the vehicle. So automated fault detection, alerting, that kind of stuff, to the level where it's feasible. I am the operations and automation team, so for me, I have to automate and operate. And so if I'm busy operating, I can't automate, and vice versa. So getting MVP and then MVP to a level where I can trust that the satellite is doing its thing in between manual operations is going to be kind of like a rollout. But the first thing is anything that will positively impact the health and safety of the vehicle. And then the other thing that operations is usually in the loop for is anything that bridges the gap between what we have on the satellite or on the ground and what we're trying to implement. So I can do manual operations for a time box period of time in between flight software updates in order to buy down risk or address things that we've found that we're trying to address in software. So having that pathway for kind of ad hoc automation almost is super valuable. So trying to send timed commands at exact cadences is really difficult. So having some sort of pathway for, okay, we can't possibly flight software design every possible eventuality that we might find in space. So what are the things that we could, the blank spaces we could use that operations could half manually, half automated take care of in between future updates. So those are the 2 most important things for me. And then long-term, how do I get myself out of operations entirely? And that it involves a lot of flight and ground software working together super well.
I think it's been my experience, not so much at Clearspace, but in previous roles, that people are much more hesitant to upgrade space-based software than ground-based software, because you have the advantage of, if you actually accidentally set something on fire, you can probably find another one on the ground, whereas
go to it and put it out instead of
exactly. Exactly. But you make a mistake in space, and if you make the wrong mistake, you've just wasted an asset worth somewhere between $1 million and $1 billion. It's not like replacing your laptop. So I think the strategy of building automation on the ground in a way that is time limited, in order to identify things to integrate into software, to vet them, and then implement them on orbit is a good way to do it. But I also think automating operations out of existence almost is also an excellent goal that I've yet to see anyone achieve. I'm going to mute for a minute while the guy runs the saw next door. Sorry.
I think
For the payload planning side of things, we're actually creating a tool on the ground side on Epsilon 3 for payload planning, ground station passes that you can utilize for payload planning on the ground. And so I think that would be really nice to connect to your flight software and all of your command and control systems. So that probably is something that you can pull in via a script and automate the generation of that. And I think starting with ground and then potentially putting it on board as you learn more is probably what I would recommend.
Yeah, I would concur with everyone else. I think it's easier and gives you more flexibility if you automate as much as you can on the ground side first. You need to have a better a mature understanding of your spacecraft and how it behaves over potentially multiple months if it's a single spacecraft, or multiple flights if it's a more advanced spacecraft like a human spacecraft. But I think trying to automate too early on board the spacecraft itself might get you frustrated because you don't know what you don't know, and you can control the ground side a lot better.
Yeah, that's a really good point, especially like with spacecrafts. You're in space, you're not in constant contact with the spacecraft. We sometimes have a contact once per orbit, which is about 95 minutes. Sometimes we have a contact not for several hours. So if we're trying to automate a bunch of things on the spacecraft this early on in flight operations, it's difficult to know what the satellite might be doing behind the scenes in between these ground contacts. So automating on the ground first, or automating things that you only are allowing to perform when they're on in contact with ground stations, is helpful to close that loop. Get instant feedback.
There's another question that I'm typing an answer to about approaching how do you think about approaching automation when it comes to conjunctions with either active or secondary satellites or debris? This might be a good Chris question if you're.
Yeah, I am all for it. I worry a little bit about the information ecosystem that we're operating in, which is a little bit underdeveloped from the standpoint of collision avoidance. If I have a system that takes in a collision avoidance warning from either the U.S. government or another space agency or authority, or a private provider like Leo Labs or someone, I can envision a day when I will be willing to have a computer look at it, evaluate it, look at the collision probabilities, and plan and fire a maneuver. But right now I don't right now we have to share that back with in my last life, we shared it back with CSPOC prior to doing it. And then they would revet the CSPOC being the U.S. military's space traffic control and observation. Somebody can help me with what it actually stands for, but they're the people who watch the junk and let you know when it's coming for you from a U.S. point of view. But we would have to provide our planned maneuvers back to ComSpoc and have those evaluated against the catalog of objects to make sure we weren't creating new potential collisions. I think there is room for automation here, but I worry that the fact that not everybody is providing the same information at the same times, and the fact that not everybody is operating under the same constraints, provides some complexity that I don't think we're ready to overcome yet. Now I know, and I suspect my fellow panelists here can speak to it more than I can, so I should probably shut up, but I know Starlink has automated, I believe, a lot of their at least intra constellation encounters to avoid crashing into themselves. I don't know that they have a ton of other interactions that they avoid automatically or not?
They do, but they still rely on data from SpaceTrack, as far as I know. So when there's contact with ground stations, I think they pull the latest like screenings, and then their onboard orbit GNC program will, try and plan a maneuver or whatever. But that also relies on, the rest of the world's debris and satellites being properly tracked and knowing which other objects are maneuverable. We've gotten at Muon, we've gotten a couple like conjunction messages recently. Conjunctions are like upcoming, like possible collision, and it gives you like a total miss distance of several hundred meters usually. So our satellite currently is not maneuverable, so we can't really do anything. So it's a little bit spooky to get one of those messages and kind of hope for the best, that the other person's going to move out of the way. A lot of times it's a Starlink, so I am pretty sure they're going to. But sometimes you just don't know. And so recently there was one that we just, I had to try and get in touch with the people who owned it, because it wasn't publicly listed on SpaceTrack if it was maneuverable or not. So I don't know if I know they have the same information, but I don't know if they can or want to get out of the way. So you're relying on, the whole ecosystem, and a lot of that ecosystem consists of just debris and anti-satellite test pieces.
Right.
And
Chris,
Also the piece that if you fully automate it, then you have maybe limited resources like propellant. Potentially you run out of propellant because you performed an automated maneuver. So you have to have some evaluation of the time criticality, the probability, and your limited resources, because in a spacecraft, one of the major limiting resources right now is propellant, on most spacecraft, not on all. But I would prefer to receive some kind of automated suggested action and then be allowed to take action or not. And you have to think that potentially the other spacecraft is performing a maneuver and have to have some decision making between the two.
Yeah. And Chris, I want to talk about Clearspace, and I think it'd be helpful to specifically go in to specific missions, and in particular your close rendezvous. Just to remind everyone, Clearspace is going in for a close rendezvous to capture space debris and deal with the space debris. But in that close rendezvous, to my understanding, there's some sort of go, no go before it goes in for the capture. Can you I think it's a really good example of bridging the gap with a human layer and automation. Can you describe that and why that checkpoint is necessary?
Absolutely. And I honestly, it's probably the folks from SpaceX who are involved in the Dragon missions. This will all ring very familiar. But we both from the point of view of kind of being groundbreaking in terms of having a robot removal mission, and from the point of view of satisfying both our client, who in the first instance will be the European Space Agency, and our regulators, whoever they turn out to be, whether it's ESA or one of the participant nations who licenses it. They are going to want to watch very carefully that we do not have a violent, let's say, collision with the thing that we are trying to capture, thus compounding the problem of debris rather than mitigating it. So we have built into the process of rendezvous and capture a series of actually go, no go points where the steps in between are automated on the spacecraft or on the ground or in some combination thereof. But the whole process gets put on hold to have a human in the loop authorization to proceed to the next step. And depending on what stage of your mission you're talking about, you may have 5 or 6 of those. And then you at some point get to the point where, I mean, these things are, 700, 800 kilometers away. And you just can't react fast enough. You have to capture this thing. And at some point you have to trust that the onboard software is going to do the right thing. And you leave it to the automation. And the onboard software is equipped to make the decision to abort if the conditions are correct up to a point, even after it's been given the approval, the go from the ground. But then at some point, it becomes more dangerous to try to avoid contact than to just complete the capture. So there's a step beyond which the computer on board will say, I'm just going to grab it. And nothing anybody can do about it. So it's a mix, I think, of being very careful not to make things worse, and using humans to keep an eye on things, and then letting the robot do its work.
And Abhi, we can toss this one to you too. You mentioned looking to automate yourself out, but can you point to certain tasks in which you require or will always need a human layer there?
Sure. Yeah. So let me give you a specific example. Once you're in a steady state operations for a spacecraft, and obviously it doesn't apply as much to human spacecraft because those missions are shorter and there's always stuff going on. But if you're doing a science mission, you're going to be in a steady state where all you're doing is upload the plan for the week, what science you want to get by pointing at what, etc. All that should be automated and run without having to have people go into the mission operations center, except for maybe uploading the final command, the plan for the week. If an anomaly occurs, however, that's when you need people. But even that can be automated. We, as Dragon operators, we got texts and emails when some alarm popped on the Dragon, and the same thing is true of our satellites that we operate out of Berkeley. If there is the need of something that is off nominal has occurred, and there's need for human intervention, we will get essentially paged by getting an email or a text saying, "Hey, your attention is needed. Now you can go in." So if you have people constantly in that operations room, you are going down the wrong track. And I think some of us, I started my career at NASA at JSC, which was all human spaceflight, and it's 24/7, 365 days a year. There are people in there. And I understand the historical reasons for that, but that wears on you as an operator team. It's not easy to maintain. It's very hard to maintain 24/7, 365 operations. So you need to figure out, how can I maximize my people's time outside of the operations room?
And maybe Laura, I'll toss this one to you. What is the role that automation has played in reducing the cost of satellite development and maybe expanding accessibility for emerging startups? You work with a lot of startups, but expanding the possibilities there.
Yeah, I think the change that we've seen in the industry over the last, I'm going to say 10 years, but maybe it's been a little bit less, is more companies are starting to try to do more with less. And what I mean by less is less people, less crazy process, less overhead. And in order to do that, you need to have really good software tools that scale with your organization. And people are seeing that the software infrastructure layer and how big it is to have a big impact on how fast they're able to move. And if you go to a legacy operator, or you go to a legacy company and you tell them, "Hey, I'm going to automate everything you do, and all you people are going to have so much time on your hands," they're going to tell you that they don't want to talk to you anymore. But if you go to them and you say, "Hey, I'm going to make your life easier because I'm going to digitize. Hey, I'm going to make your life easier because we're going to give you some automated readouts on pass-fail criteria. Hey, I'm going to then tell you that you can press go to run this test or run this piece of your operations." You have to do things piecemeal. And so, we're seeing new companies come out that really want to invest in the infrastructure. And so, Epsilon 3 is here to support that. And we're also seeing older, more established companies want to learn about the digital side of how fast they can move with, better software tools or better automation. And so there's a big shift, and I think that it's going to continue to grow. Sorry, that was very long-winded.
Yeah, in my experience, that is exactly correct, Laura. People who have been operating satellites since the dawn of satellites, have a very specific way of doing things, and it's difficult to kind of think about like relinquishing control of what you've been doing for your entire career. So I think it's important for, from my perspective in the program that I was on at SpaceX, like one of the things that we wanted to do was kind of take a tour of the facilities where these people were previously operating their satellites, to get an understanding of like what they see, what the story is to them of like satellite and space operations, so that we can kind of start to explain to them in their language, on their terms, like what things we're going to improve. So it's not just, oh, I'm going to automate your job away. It's what things in your life would be improved if X, Y, or Z were changed, taking their story and like writing the sequel to it almost.
Yeah, I noticed there's a question in the question box that sort of pertains to this. A question from Al Tedros. The level of spacecraft automation over the last 30 years seems to have incrementally advanced, which is a bit surprising compared to terrestrial systems. Other than capex of space systems, are there technical reasons you see why space system automation hasn't advanced more? To me, what I see as the reason for this is simply iteration time. Our industry historically has done bespoke spacecraft, and you can't automate things until you have a large enough data set to understand the different permutations. So now that you have larger fleets coming into the ecosystem, Starlink obviously being the big behemoth, but not just Starlink, Planet Labs, other folks that are doing constellations, I think you're going to have enough data and enough permutations among all these satellites that now you can decide what to automate. I think the same thing is true of the F9, for example. When the F9 first started landing on land and on the barge, folks didn't quite know, what was the reliable parts, what were the unreliable parts. And here I'm making a hardware analogy, right? You had to get enough of those things back to figure out, oh, this is the pain point. This is the thing that keeps breaking after 2 landings. And I think making that analogy now to the automation world, when it comes to our spacecraft, we sort of need the same thing. So I think you're going to see all of a sudden more automation on the spacecraft side in flight as we get larger and larger sets of data from these fleets.
Everybody today is talking about AI and machine learning and whatnot, and I think this is a really good target for AI and machine learning. Frankly, I previously worked for a company that ran a small constellation of satellites, and even we felt like we started to have enough data after a few years of multiple satellites in orbit. We started to have enough data that we could apply machine learning techniques to try to identify anomalies before they would be identifiable from traditional metrics, where you set a threshold in your telemetry system and it goes out of bounds and an alarm goes off. We had some success in identifying things before they got to that point using machine learning techniques. And I think as we get larger constellations and more satellite years of operation, the people who have access to that data will have the opportunity to implement some of the cutting edge data techniques that are populating everything now. If you believe the news, yeah.
Yeah.
Are you at Epsilon 3 looking to implement any machine learning or AI software into your product?
We are. Part of our product allows the users to upload and track a lot of their telemetry data. And so we are helping them utilize that data in ways that Chris just mentioned. And so I think that goes a lot into kind of our future and what we're looking to help some of our companies, our support and customers with. Sorry, Paige, go ahead.
I don't know if what I was going to say is relevant anymore, but I was just going to mention before, like the hesitance to kind of improve automation. A lot of that is just legacy. Like the space program has been around in some form or another for 60 years, and it's really hard to kind of break out of established methods of doing things. I briefly worked at an old aerospace company in my before space flight. And it just was insane how just everything is just red tape and paperwork. And I'm like, I think that regulations are important and I think that safety is important, but I think that there's arguments to be made for, changing the way things are done in an established company. And I think a lot of that is just like hesitance to, change the status quo and change what legacy companies have been doing for so long. And government also has a lot of, and aerospace and defense are very closely tied together. Whether or not you're working directly on defense, aerospace and defense are, two kind of peas in a pod. And so a lot of defense requirements slow down a lot of development in aerospace.
I previously worked 25 years purely in commercial space and mainly with what we call now new space companies. So not the traditional defense contractors and not NASA or the military, purely commercial. With Clearspace, we're involved in several contracts with either the European Space Agency or another space agency. And the difference in just the amount of paperwork that has to be generated to get approval to proceed from one review to the next is astonishing. And without automating test reports and the like, I don't know how you would do it without building a 10,000 person military industrial complex company. And I will say Epsilon 3 has been a huge help there for us. And I envision it being even bigger in the future as we move further into our integration and test regime.
Thanks, Chris. Glad to hear it. We've got a couple more questions, unless we should. There's one about Chris. It says they'd like to know more about what the user should ideally be able to interface with the automation that is running or acting. Chris, you mentioned setting thresholds, and I mentioned wanting to receive recommendations and allowing whether the human should act on it. I think Paige is typing an answer, but I think we could do more on that.
Does this go back to the question on collision avoidance automation?
I think it's a little bit in that
vein, yeah.
When automation is running either on the spacecraft or the ground, should or can the user, the operator, intervene? And how do you make that decision and the distinction?
In spacecraft operations, it's pretty complex because if automation is running on the spacecraft, like I mentioned earlier, there's not always a closed loop, so you can't always know what's happening. There can be long gaps in between coverage, like you don't have an Ethernet cable connected to your satellite at all times. Depending on what your ground coverage looks like, there's going to be some mystery inherent in the system. So you have to decide, during test or while implementing these features, what things you want to always trust the process. And there's gonna, you can't always, caution is good, but you can't always have enough coverage or bandwidth to have people always intervene. So testing a lot, constant integration, constant development, always making sure that you test like you fly as closely as possible. And then also my like personal philosophy for trying to implement automation is I will try things live first and kind of get a ConOps around, doing X, Y, or Z for like recovering from this alert or, trying to diagnose a failure condition. And then if it's repeatable, if I've been able to accurately predict when this one thing is happening and nothing else is happening, because if something else is also happening at the same time, are those two things going to interfere? Kind of piecemeal, I guess, developing those things. And then eventually, like you can't do that for every issue that comes up. So there's got to be some sort of, and that's why, engineers are.
I also think you have to, you have to answer that question from the perspective of what is your organization trying to accomplish. If you're an organization that is always going to be operating pretty one-off bespoke spacecraft, then concentrate almost all of your automation on the ground side. You're never going to have it's never going to be worth your while to push really hard to automate a very bespoke spacecraft. If, on the other hand, you are operating a large fleet like, Starlink or some of the other ones I mentioned, then as you collect more data, you want to take the operator out of the loop more and more once, like Paige said, you've kind of tested out your ConOps and you know what needs to be done. But for some of the folks that are tied in, if your organization really just does batches of one-off, either a single spacecraft or batches of constellations of like 3 or 5 or 10, and then you move on to a different type of constellation, spend like all of your energy on ground side and tool automation versus trying to get stuff onto the spacecraft.
And generally, when you're thinking about automation, are you primarily thinking of it as a way to reduce time burden on employees, or are you thinking of it as a way to reduce risk in the mission?
For me, I think I personally look at it as both. There's another category of things we haven't talked about yet, which is, and it relates to burden as well. I think the whole COVID situation, when it happened in 2020 and forced at some companies people to work from home a lot more, it was a burden, but at the same instance, it opened up an opportunity as well. At Berkeley, we developed a set of tools to allow, I'm not saying execute because the execution would need permissions, but allow people to operate spacecraft from their kitchen tables. Okay. So putting in the physical infrastructure for that and the software for that, I think was an example of ground side automation that reduced burden. If I have an anomaly in the middle of the night, yes, I have operators that can go in, but wouldn't it be cool if that same operator could just flip open their laptop on their kitchen table and do the vast majority of what they needed to be done there? So I think I do not undersell the burden. It's hard to keep people in this industry because there's a lot of opportunities. And so you really want to make sure that you're not unnecessarily making them come in for things that everyone acknowledges that with a little bit of work, you should be able to do that from your kitchen table.
There's also like considerations based on the importance of the mission and also mission duration. So if you have like a one-off bespoke satellite and it's supposed to operate for 10 years, what continuity can you really expect from your operations team over that long a period of time? And in that case, if you have a very small team of operators for a satellite with a duration of 10 years or, whatever, some reasonable amount of time, it might be worth it to invest in more automation to just to kind of help with that continuity. And then also the nice thing about, I guess, software is that it's not hardware, right? You're not stuck with what you fly with. We've done a handful of software updates on orbit already for our satellite. So it launched with hardware that we weren't using yet, and we have enabled features as we've gone. So that is almost always a possibility, is to, throughout the life of the mission, make upgrades that will make everybody's lives easier. And so I think that kind of goes back to one of the things I was saying before, is to have some sort of infrastructure in place so that in between those updates, you can handle issues that you didn't necessarily anticipate in a way that's repeatable and safe. And always with the idea of like prolonging mission life and improving mission safety.
There was a question that Abhi answered that I wanted to answer also live. He talked about the business case of why you would automate, and if it ain't broke, don't fix it. Well, that philosophy is a philosophy that I lived in my previous life, like how Paige was when I was at Northrop Grumman. It's everything is working. We shouldn't change anything. And that is, they are very reliable, but they don't change things. Whereas at SpaceX, and now with a lot of the companies that we at Epsilon 3 work with, they want to do as much as possible, as fast as possible. And it depends on your company's mission. If your company's mission is to be, slow and steady, wins the race, very reliable, very, manual, then you probably aren't going to win the business case on why we should automate things. If you have 100 people to do the job of 100 people, then you probably aren't going to win that discussion either. But if you have 10 people to do the job of 50 people, you probably are going to win that, future leaning. Hey, we should continue to be forward leaning and look to automate ourselves out of the job. So I would just look at it from the
Laura, I'm sorry. The way I answer that question, very consistent with you.
Yeah.
It comes down to your individual company's philosophy of opportunity cost. Okay. So at SpaceX, pretty much the biggest cost that, the exec team always looked at was the opportunity cost. If my people are working on this thing, okay, what is it preventing us from doing? Right. So if you're at a company where, you don't have another big program, or you don't care to pursue another big program, you're good with one thing at a time, then there's no business case to take your people and make them do further automation. If you're at a company that's scaling and is constantly getting more work, you have to get your people off that older program as fast as possible and shift them, or you're dead in the water and you cannot scale and your money will dry up. So when you're at an organization where those people and their time is the most valuable thing, it is a very easy to make the business case that we need to automate. It's simple. And if your leadership pushes back against that, I would quit that place because that company's doomed. I put it that way.
Also, there's investment in one or two or n extra software people to help automate versus a dedicated consistent perpetual fleet of operators. Currently at Muon, we have one operator per satellite because it's me and one satellite, and that doesn't scale. If we have more people to implement automation, we can get to a small core of operations team that can operate a satellite fleet of any size, really. So the opportunities for bringing in income versus spending money on headcount and personnel is I think that's a good business case to be made as well.
And we have about 5 more minutes in this webinar. I want to turn our attention to the future, just some big ideas, or just how we see the evolution of automation in satellites progressing over the next 5 years. So maybe Laura, you could kind of take that question. What do you see as kind of the next 5 years of satellite automation?
Sure. So I think a lot of satellite automation will be growing for flight software. And then with respect to ground software, you're going to have data sets that you need to utilize. I know somebody asked about space weather, to make decisions on what happens with your satellites. So ground-based systems, ground stations, or potential collision avoidance maneuvers. So you have external data sources that your satellite may or may not have access to, that you're going to need to perform maybe decision making on whether or not you perform a maneuver or rendezvous. And I think there will be, in concert with that, more automation on the ground as well, so that the operator can intervene if needed, but the satellite and the ground stations and the ground systems all take care of themselves. So like what Paige said, you have 1 or 3 people, maybe on 8-hour monitoring on call, to basically take care of an entire fleet of satellites. And maybe you might need 3 people for a human spaceflight mission, but you probably don't need 40. And I'm hoping that that's where we get, because if we have multiple private space stations, huge constellations, lots of human launches and rendezvous, you're going to have a lot of different operations teams around the world that need to be not 40 people. They need to be 3-4 people. So anyway, that's my take on it.
And Chris, maybe you can jump in there too, and maybe vis-a-vis Clearspace, is there ever a scenario in which you could see maybe satellites being completely automated, or you don't have those no-goes? How do you see the next 5 years, 10 years progressing?
Yeah, I think absolutely. That's the dream, right? You launch a spacecraft and it's up there, and then you have somebody come and tell you that it needs servicing, whether that be capture and deorbit or capture and refuel or capture and replace batteries or unjam the widget that's jammed in my Wickersham or whatever. I don't know what, pick a thing you could do. I think all of the dream is you just point your satellite to it, tell the satellite the mission, and it goes and does it with minimal oversight. I think as we get more of these missions, both crewed and uncrewed robotic missions, our clients and our regulators and our insurers and everybody else, our money people, will get much more comfortable with the idea of additional automation. I think it's, we're still on the front side of that hump where we have to demonstrate we can actually do this effectively and safely. And as we prove that, we will start to get the freedom to use more automation. And I fully envision fully robotic. I fully envision all sorts of things. I envision fully robotic missions in the next, decade and a half.
Yeah. And Paige, we can toss that to you as well. And maybe is there a specific dream automation that you're dreaming up right now, but maybe it's like here's the future because technically we're not there yet, that you could share with us?
Yeah, I think my ideal situation would be having like 85% of things that could happen solve themselves. Having automated fault detection routines on board the spacecraft, in addition to like the handoff between the ground where you can post-process data and respond to things after the fact. There's always going to be some things that come up. So I think there's never going to be a situation where there's no operations in the loop required. But I think that we can get pretty close with good engineering and good software, and a good understanding of like the systems and how they work together. The future's bright.
Great. And Abhi, you want to comment, make it the last comment of the webinar?
Yeah, I think, I'm all for more automation, but the one slight caution I want to give to everyone, like, for example, tools like Epsilon 3 are great. We're integrating it into our ecosystem, but do not underestimate the need for really good people to stitch these things together. It's what we call the glueware, okay? So there is no everything software that will automate all parts of your ground. It doesn't exist, and it won't exist for probably a long time, if ever. And so we're in a situation where you might see a very attractive software package from one company that will help you automate, and another software package from another company that might help you automate. So do not underestimate the need for really sharp people and talented people to stitch those things together. Because right now, and for the foreseeable future, everyone's suite of tools, their ecosystem is going to be slightly bespoke. And so you got to have smart people that know what to stitch together and how, versus what to wait until it's better in terms of automation before trying to incorporate it as well.
Great. Well, Laura, Abhi, Chris, and Paige, this has been awesome. I think this is a great discussion on automation and the future of automation, and also kind of how it's driving startups. A lot of you working at startups along. So I want to thank you all, the four of you, for joining today, and everyone in the audience. I appreciate everyone tuning in. This has been great. So yeah, thank you all.
Thank you so much for having me. This was super fun.
Yeah.
Thank you.
Thank you.
Thank you, guys.